Hello, I'm Mr. Becker, and in this series of videos I will make sure that if you are taking the geometry regions, the common core, that you will pass it. I have created, look, a handout, well, packet, whatever you want to call it, and it has all the problems that you need to learn in order to pass the common core geometry regions. So I will go through a series of problems. Some of them I will explain in detail, and I might deviate and try to explain the whole topic in detail. But I promise you that after this series of videos, you will pass your common core geometry regions, which can be used to substitute for a global history or US history. Okay? Even if you haven't passed the common core algebra, you could replace that with this one. Okay? That's it. Alright, so I'm gonna start now. Okay then. So let's get started. These are the tools that you will need in order to be successful in passing the common core geometry regions. You need a calculator. It could be a TI-84 plus CE or a TI-84 plus, okay, or a TI-84. You need a compass, the thing that makes circles, pencil, and of course a ruler. Okay, so let's start. The first thing I'm going to teach you, okay, is the basics. I am going to teach you how to construct a perpendicular bisector. So look, draw a line segment, right? Let's say we have a line segment like this, and we have the endpoints. So we have endpoint A and endpoint B. So how to construct the perpendicular bisector? Well, I'm only going to teach you two ways of doing it, because more than that might get you confused. Take compass and open to the length of your segment. See that? And trace a semicircle. Now, place compass on point B and trace circle B or semicircle B. See that? Now, the intersection, you connect. And voila, my friends, that's your perpendicular bisector. This is your perpendicular bisector. Perpendicular because it forms 90 degrees, and bisector because it divides AB into two segments. Let's call this point E. So basically AE is congruent to point EB. That's it, perpendicular bisector. I'm not gonna do another, oh yeah, I have to show you the other way. The other way, okay, is the following, or actually I can do it on the same line segment. So in this case, you don't have to open the compass to the length of AB. You could just you only have to open it to more than halfway. Got it? Okay, so look, I do again the semicircle. Then I'm gonna go to point B again, you know, and draw another semicircle. And as you can notice, look, both semicircles intersect at the same spot as the big ones. All right? So that's it. That's how you construct your perpendicular bisector. Don't forget, because that's basically the most basic and the most needed construction of them all. All right, now I'm going to show you how to construct an angle bisector. If you have an angle like that, and you want to construct the angle bisector, let's label this A, B, and C. It really doesn't matter. So this is angle BAC or CAB, however. So to construct the angle bisector, go to vertex, okay, and swing an arc of your choice. Okay, the length is arbitrary. You could choose whatever length. So look, trace an arc. Label the points where the arc intersects the angles. The rays. Okay, and now open compass to measure of the arc. See that? So now, once you have it at the length of the arc, then draw another semicircle. Now go to this point everything is without changing the length of the compass. And draw your other semicircle. See that? So now this is the point where the two semicircles intersect. So now from the vertex, you're gonna go and, wow, why did it come out like that? Okay, better. So this is your angle bisector. Never mind this line. I don't know how the hell it came out to be like that. Okay, so that means that this angle, because the angle bisector divides the whole angle into two congruent angles. So angle bisector. Last but not least, listen to me. You are always entitled, okay? Let's say you want to draw a perpendicular to a line. So let's have the line. Let's have this line segment, whatever, or a line. So it's a line, and you have a point right here. Okay, and you want to draw a line perpendicular to it. Well, we're going to utilize the concept of the perpendicular bisector. But first, we need to create our segment. Remember, this is a line. So a line extends infinitely. So we have to create a line segment. So what you're going to do is you're going to create a circle that intersects this line twice. So I'm going to open it. So I'm going to intersect this line right here. Okay, see that? And I'm going to intersect it on the other side. Holy shoot, oh my God, I have a problem. This doesn't intersect the line twice. Well, who cares? Look, you are always allowed, in geometry, you are always allowed to extend any line that you want. Ooh, voila. And guess what? Now I have my own line segment, which I'm gonna call AB. Cool? Well, why do I need this? Well, in order for you to create a perpendicular, you need to create your own line segment. Now what? From your new line segment, you're gonna construct the perpendicular bisector. And you already know how. Open to the length of your new segment, right? Or if you want to, more than halfway, really doesn't matter. I'm just gonna keep doing to the length of the segment. And I create my semicircle. See that? I'm gonna go to B, and I'm gonna trace my other semicircle. Now I'm gonna connect them. I'm gonna connect the points of intersection. And my friends, this segment or this line is perpendicular to this line. Yes, it is the midpoint of your new line segment, but remember, it is the midpoint here, but not of the line. A line extends infinitely. So this is just the perpendicular line. Now, why is this useful? Well, I'm gonna explain to you why this is useful. Let's say that you had a triangle. You had a triangle. You had a triangle. Oh, I caught you. You had a triangle, right? And they ask you, construct an altitude. What the hell is an altitude? Well, in plain English, an altitude goes from a vertex, any vertex of the triangle, and is perpendicular to the opposite side. Okay? And that's it. So that's how you create an altitude. Now we're ready to start our problems. So we did perpendicular bisector, angle bisector, and we constructed a perpendicular from a point not on the line, which in reality, it's called an altitude of a triangle. All right, a triangle has three altitudes, and actually, you know what? Let me draw a triangle. Let me show you a triangle, and let me show you how to draw an altitude. So I'm gonna create any triangle. I don't know how to create a triangle. I'm just gonna go like this, a boom, and I'm gonna go like this. Yeah, something like that, and I'm gonna go like this. All right. So that's my triangle. I'm gonna call it A, B, and C. This A looks like a triangle, son. Ooh, oh damn. Whatever. Okay. So, let's say they want you to construct an altitude from vertex A. Okay, cool then. So you know what? I'm gonna make it more comfortable for me, and I'm gonna put the paper like this. So what do I know about the altitude? The altitude is the same construction as constructing a perpendicular from a point. This is the line segment or the line, and this is your point. So what do I do? Well, the altitude needs to be perpendicular to the opposite side. coming from the vertex. So then you know what? Let's create our own line segment. The line segment has to intersect this side twice. So I'm gonna do it like this. And as you can see, it does not intersect it twice. Well, you know what? Who cares? I told you already, you are entitled to extend your line as much as you want to. Oh, beautiful. Now it does. So I have my new line segment comes from here and the other intersection, which is right here. And now you're going to construct the perpendicular bisector. So look, open compass all the way to point B, like that, and draw a semicircle. Oh yeah, okay. And now here, ooh, point B, not on the triangle, but point B, your new point of intersection. Yo, Bex, what's up? You didn't draw the whole semicircle. Yes, son, because I'm not interested in the whole semicircle. I just care about the point of intersection. You understand what I'm saying? Yes, I do. Yes, I do. So look, my friends, this line right here is perpendicular to the opposite side of the triangle coming from this point. So that is your altitude. Every triangle has 3 altitudes. Got it? Okay, cool then. So now we're ready. It says, and this is your first problem. Okay. Using a compass and a straight edge, construct an altitude of triangle ABC below. Leave all the construction marks. All right. It says construct an altitude. It doesn't say what altitude. I could go from B, from A to C. I really don't care which one. So it's your choice. I already gave you the steps. If you still in doubt, go back and watch it again. Look, I'm gonna do 2 altitudes just to show you. I'm gonna drop an altitude from A going to the opposite side, BC. Notice the altitude needs to be perpendicular to the side, okay? But as I can see, if I draw, I need to create my own segment. So okay, so let me create my own segment. Look, I'm gonna intersect it once, and as you can see, there's nothing here. So you know what I'm entitled to do, right? So I'm gonna go from point here, and I'm gonna extend it. Now I have created my own segment. So look, right here, right here. That's my new segment. I could call it whatever, CDs or C or K, KM, I really don't care. But the thing is that right after you create your own line segment, then you have to create the perpendicular bisector. So look, I showed you 2 ways of constructing the perpendicular bisector. One, I said, extend the compass to the length of your new segment, right? So that's what I'm gonna do. Look, awesome. I'm gonna make this smaller, hopefully you could see. Okay, look. And now I'm gonna go to my other point M, and I'm gonna do the other segment. See that? And now I am going to connect both of them. But in reality, guys, you don't have to connect all of them. All you have to do is go from here to here, because they just want the altitude. If this side was like extended all the way, then this line segment will be the altitude and it will be perpendicular. So I did that. Now, Bex, did you really have to like OD on this one? Nah, not really. Remember what I showed you before? You could just move more than halfway. So if I go more than halfway, look, this is what happened. Semicircle here. I still go to M, okay? Semicircle here, and guess what? The line still goes through the intersection points. So you can't go wrong with that. All right, let's move on. All right, once again, I'm gonna have to take my time with this one. It says, copy this angle over here. That's what it says. So I can copy this angle in 3 different ways. Copying a side then an angle, and then another side. Or I could copy 2 angles and a side. Or I can copy all 3 sides. So today I am going to focus on this one. And unfortunately, I gave you the answer without knowing. Look, it says, based on your construction, state the theorem that justifies why this triangle is congruent, meaning the same size as this other triangle. All right, so let's get to work on our technology. We can make this triangle better, faster. So do me a favor. The triangle's name here is XZY or ZXY. I really don't care. I really don't care about the name as long as you keep it consistent. So do me a favor. The first thing we always copy is the base. So you see this base right here, XY. Take your, we're copying all sides. So you know what? It's not like you're gonna take the ruler and say, oh, 1 inch, oh, 1 inch. It doesn't work like that. You have to leave all the construction marks. So look, I am going to take the measure of XY with the compass. See that? See this? Look, that's XY. So you're gonna go somewhere on this line, and you're gonna put a, you know what? Put a point, okay? You're gonna name a point. This point right here, you know what I'm gonna call it? I'm gonna call it X prime. X prime corresponds to X. So since I have the same length here, I'm gonna go to X prime and I am going to do an arc. See that? Or you could do a circle, I really don't care. Guess what? If this is X prime and I open the length of the compass to this side, then this should be Y prime. Am I making sense? Yes, right? Oh, okay. Now let's go to, we're gonna copy segment XZ. So you open the compass to the length of your segment XZ. You see that? Okay then. So now that I have the same length, remember I went from X to Z. So definitely I'm gonna have to go from X prime to somewhere. So you're going to do an arc long enough, just in case, see, like a semicircle. So somewhere in here, this length is XZ. So somewhere in here, anywhere I go in here, the length is XZ. But now I need to know what's going on. Where is that XZ gonna be? Well, we're gonna copy the last side, which is YZ. See that, guys? Open the compass to YZ. And you're gonna go to, remember you did YZ, so you're gonna go Y prime and just gonna swing an arc long enough that it intersects the other one. Because this length was XZ. This other length is YZ. The point where they intersect, that is going to be Z prime. So now, good riddance, Pungi. Dike, despacito. Waka chocotico. So look, I copied the triangle. This triangle is congruent to this triangle right here. Okay? Better like that? Trust me, it is. You think they look different? They don't. Maybe I need to do this like that. All right? So that's how you copy an angle, using all 3 sides to do it. All right, cool then. I'm done with this first page. Let's move on to the next exercises. All righty, what does it say here? Construct an equilateral triangle inscribed in circle T. So this is your circle T. How do you construct an equilateral triangle inscribed? Inscribed means that it fits perfectly inside the circle. Do me a favor. Go and trace the radius. The radius goes from the center to somewhere in the circle. So this is gonna be your starting point. That's how you construct an equilateral triangle inside the circle. So open compass to the length of your radius. Beautiful? Yeah, beautiful. So now that you have this length, okay, you're going to go to your initial mark and follow my lead. Then go to the mark that you made. You go to the mark that you made. Despacito. Awagamagashaga laka ng coquito. Watamagasuka laka marasito. Oh yeah. That's it. Look. And this is the last mark, which is right here. Now, this is the construction of a hexagon. I think if you connect all the edges, you're gonna end up with a hexagon which has 6 sides. But hexagon has 6 sides, triangle has 3, so it's half. So therefore you don't need to connect all these marks. You're only gonna connect every other mark. So from here, you're gonna connect this mark. You're gonna skip that one. From here, you're gonna skip this one and connect this mark. Got it? Ready, set. And beautiful equilateral triangle. You don't think this is an equilateral triangle? Maybe you want to look at it like that? Yeah, you like it? Yeah, of course you do. Thank you very much. Okie dokie. Now to the next problem. Guys, I'm doing just 1 or 2 of each problem, so make sure you learn it. In other words, go back and do it. And you know what? If you have a compass, draw circles and keep on doing this, because this practice makes perfect. You will understand this. All right? Anyway, what do they want here? They want use a compass and a straight edge to construct an inscribed square in circle T shown below. Leave all construction marks. So now I need an inscribed square. How the hell am I gonna do a square? Easy, guys. Draw a diameter. A diameter goes. See, I got the center, so anywhere I go from the circle that passes through the center, any chord that I draw is gonna be a diameter. So I'm gonna do this. That's my diameter, right? So now label this point A and this point B, or M or C. I really don't care. You got diameter, right? AB. Then to finalize your construction, construct a perpendicular bisector. The what? Perpendicular bisector. You forgot? Take compass on point A, open to point B, like that. And now look, trace 2 semicircles. Maybe I should do this smaller, because I'm a good student. So a smaller, half circle, and now you go to point B. Not point T, I don't know. Some people just, by nature, they decide to go to point P, and I don't understand why. So that's it, right? And now, people, connect the points of intersection. All right, my friends. If I told you that you're done with the construction, I'm lying. This is not a square yet. Yes, you have everything else done. So now, you're gonna label these points C and D. If the points are already taken, then use other points. X, Y, B, T, whatever, I don't care. Now, my friends, connect all 4 points that you have. I'm nervous, I'm nervous, I'm nervous, I'm nervous, I'm nervous. Beautiful. Oh yeah, oh yeah, oh yeah, oh yeah, oh yeah. Yes, I got it. A square, my friends. Diamond, well, square. Diamond, square. Square, I caught you. All right then. So that's basically how you do it. You're not gonna just measure with a ruler. And by the way, remember, each of these is a right angle. I'm just letting you know, each of these is a right angle. And now let's talk about something that we need to know. Okay, we have something called, and I'm gonna actually do it on this. Okay, you don't have to do it. I'm just gonna show you. So I have a circle, right? And this is the center, right? So we have something called a central angle that goes from the center. Okay? So why are you showing us that? Well, you'll see why. So let's call this central angle theta, or theta in English, or theta in Spanish. I really don't care. The central angle, because it goes from the center, will always be equal to the length in degrees of the arc that it cuts. So this is the arc that it cuts, an arc of, I don't know, let's call it 80 degrees, just for the sake of. So, well, if the arc that the central angle intersects is 80 degrees, then the angle is also 80 degrees. Okay. Well, this is for the central angle. You should write central. But what happens when there's another angle? Okay. When there's another angle that intersects the same arc. Okay, what happens when there's another angle? This angle right here that intersects the same arc, but it goes from the circle, from a point on the circle. The vertex is on the circle. Well, it is half the arc that it intersects. Make sense? Yeah. Well, that is the reason why I say that this is 90 degrees. I know that all squares, we know that all squares have 90 degrees angles, right? But look at the arc that this 90-degree angle cuts. It cuts a semicircle. And we know that the full circle has 360 degrees. So half of this arc is 180 degrees. Therefore, this is 90. Make sense? Okay. So I hope you understood this. This is what we call an inscribed angle, and this is what you call a central angle, because it goes from the center. Okay. Let's see now. Using a straight edge and a compass, construct a square inscribed in circle O. Leave all construction marks. So easy. Same thing as we did before. Draw a diameter. This time I'm going to do the diameter like this. A diameter is a diameter however you do it, as long as it goes through the center. Okay? And now I'm going to tilt it like this. And now the next step is to construct the perpendicular bisector. So we're going to label this A, K, I don't know, A, B, whatever. Open compass to length of diameter, right? And draw semicircle. Open compass to length, sorry, not open compass. Leave compass the same way it is. Okay? And now, connect points of intersection. Okay? Now, label the points where the line, where the perpendicular bisector touches the circle, label them, I don't know, CD? Whatever. And now, we are just going to connect the points. Oh my god. Yara 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 yamero. Jotaro jojo. Eno peno se que tokete. Oh my god, beautiful, right? Square. Okay. So now, the next question. What the hell is it? It says something about determine the measure of the arc intersected by the two adjacent sides of the constructed square. Explain your reasoning. All right. So look. Adjacent sides are sides that are joined by a vertex. So this is adjacent to this one, or this one with this one, or this one with this one. Got it? Okay. So this side, let's just take a look at these two adjacent sides. Okay. So let's say we don't know that this is 90. Okay. What they want us to do is to determine the measure of the arc. Fine. Look. This is 90 degrees. But let's say we don't know. So this angle ACK, okay, intersects an arc that is half of the circle. And half of the circle, an arc that is half of the circle, measures 180 degrees. Oh my God, sorry. Let's go back to the explanation. Oh my God, I wasn't looking. Okay, so this angle intersects half of the circle. It intersects an arc that is half of the circle. So you could say angle ACK, or angle C, if you want to, okay, is equal to 90 degrees. Okay, because in a square, all four angles are 90 degrees. Then we say that adjacent sides, okay, the adjacent sides of the square intersect an arc that is equivalent to half of the circle. And since this is an inscribed angle, it measures half of the arc. Therefore, the arc is double of the angle. So if the angle is 90 degrees, then this is 180 degrees. The arc measures 180 degrees. Got it? All right then. So that is the explanation that you're going to write over here. So you could say the arc. Let me see if I have a... Do I have a pen to write with? I really don't. I don't want to be looking for... But anyways. So I'm going to say the following, and I'm going to have to write that over here. Okay. So the arc intersected by the two adjacent, or by two adjacent sides of the square, okay, has a measure of 180 degrees. Okay, because what else can I write? What else did I say? As a measure of 100 degrees, because ACK, in this case ACK, you could have written ACM, AC, whatever letters, right? So because ACK, okay, this angle, okay, ACK is a right angle, okay, which equals 90 degrees. It's a right angle which equals 90 degrees, and it is also an inscribed angle whose measure is half of the arc it intersects. Okay, and you could go on and say, and the arc that it intersects is half of the circle, and the circle measures 360, so half of that is 180. So that's why. See that? All right, let's move on. I did this, I did that. Number 6. All right. What it says? In the diagram below, radius OA is drawn in circle O. Using a compass and straight, construct a line tangent to circle O. What the hell? A line tangent. What do I know about tangents? Tangents, I know. A tangent line is a line that only touches the circle once. Okay, so how do I do this? Easy. All you need to do is double this distance and construct the perpendicular bisector of that. Yeah, but how do I do this? Duh. You're not using a ruler, remember? So, open compass to length of OA, right? Yes? And then go to A and swing arc. Now take ruler and extend OA so you know where that is. So you just double this distance. So, okay now. So now you have a segment O, what do you call this? OP, right? You wanna call that? Okay. So I have my new segment OP because I double it. And now I'm gonna construct the perpendicular bisector. I'm gonna just tilt this a little bit. And let's see what happens. What happens? Open compass to length of your segment. Yes? Beautiful. And draw semicircle. Let's see if it works. Let me go with that. Oh, okay. Draw semicircle. Oh, it fits. It fits. And now I am going to do the same thing from point P. See that? Beautiful, right? So now I take ruler and I connect. No way. Let me see. See, is that gonna do it? Well, let's see. Hopefully it does it. Oh, gosh, Bex, you are the awesomeness of awesomeness. Constructed a tangent line. How did I do it? Double the distance from here to here and construct the perpendicular bisector. But anyway, remember something. I open it to all the whole length. You don't have to do that. You could just open it to more than halfway. And look, could have done this. Go here. You could have done that. And it's the same thing. See that? Just in case you run out of space. All right. So let's move on. So here, what does it say? It says in the diagram of ABC, so below, oh sorry, in the diagram of ABC shown below, this is ABC. Okay, use a compass and a straight edge to construct the median of AB. The what? The median, son. You don't know what the median is? No. The median goes from a vertex to the midpoint, from a vertex to the midpoint, from a vertex to the midpoint of the opposite side opposite to the vertex. Oh yeah, I got it. Okay, relax. So I could do it in any way I want to, right? No, homie. It says construct the median to AB. So they want me to construct something that goes from somewhere to AB. Well, if I find the median from AB, I have to connect it with angle C. All right, so how do I do that? Median, man, come on, midpoint. What the hell is wrong with you? And but how do I find the midpoint? You know what? You get on my nerves. The midpoint is found by finding the midpoint. Yeah, I said that already. Well, there is a construction that allows you to find the midpoint. The perpendicular bisector. I don't know why I spend so much money on this guy. So look, open to the length of the segment, and you know what's gonna happen? I'm gonna show you what's gonna happen. This is gonna happen. This is gonna happen. I'm gonna ruin my beautiful whatever this is. So, remember what I said before? You could use the other technique where you don't have to open it the whole length. Oh, you mean like just more than halfway? Yes. So then if you open it more than halfway, you still draw the semicircles. You see that? From A, and now I'm gonna go to B. Yo, Bex, you're the best. Yes. All right. So this is what happened, guys. You could trace the perpendicular bisector all you want to, like that. Or, since you already have the construction, you're not gonna lose points. Or you could just point at the midpoint. That's the midpoint. Yeah, so why? Well, that's all you need. Now look, go from angle C and go to your midpoint, and my friends, your median. I present you the almighty median. Bex, I don't know what I would do without you. You're the best. All right, and I leave all the construction marks. So just make sure that you don't forget about the perpendicular bisector. Okay. What the hell? Using a compass and a straight edge, construct and label A prime, B prime, C prime, the image of ABC after a dilation with a scale factor of 2, center at B. What the wow, okay. Label construction marks. Describe the relationship between the lengths of AC and A prime, C prime. All right, I'm gonna tell you something. I really gonna have difficulties with this. So I'm supposed to dilate this figure. I'm used to dilating on the coordinate plane. I'm not used to dilating just like that. But you know what? I'm gangster. I'm gangster. See, I caught you and I caught you. Exactly. So dilating something means making it big, no, not bigger. Yeah, bigger or longer. Or shrinking it as well. For example, females, when they give birth, they have to get dilated. Okay? After they give birth, then they go through a shrinkage process. What else can I say? Okay, when you inflate a balloon, that balloon gets bigger, it gets dilated. When you deflate it, it becomes smaller. Get it? Awesome. So then, that's what I'm gonna do here. They said that the scale factor is 2. So look, scale factor is 2. A dilation can only be bigger, longer, or whatever, or smaller by means of multiplication or division. So if it becomes smaller, it's like you're dividing or multiplying by a fraction. If it becomes bigger, it's because you're multiplying by a whole number, a bigger number, right? So let's see now. The center of dilation is very important because the center of dilation never moves. They said that is B. So how would you dilate this at a scale factor of 2 if you don't have anything here? You don't need to. Look, from B, which is the center of dilation, go to C. Guess what? The scale factor is 2. That means it's gonna become twice as big. So I'll go again here and look. See that? And now I go from B and I go all the way here. Or if I could even pass it. I know that this is the point that I need. So this length, okay, what did I dilate? I dilated C. So this is gonna be called C prime. Hopefully that makes sense. Now I'm going to dilate A. Okay. So look. Actually, this is mathematics. Go to, okay, open compass to point A. Oh, a little longer. Okay. You see, this is BA, right? And you know what happens? Since the scale factor is 2, then I gotta go again. Make it twice as big. Beautiful. And now, my friends, extend. Remember, B is the center of dilation. B does not move. That's what you have. And now, this is gonna be called A prime. Because I just dilated A. B, my friends, it's its own B prime because it does not move. And always remember, when you dilate, look at this. It's like we're dilating this line. When we dilate a line, we create a parallel line. Always remember, believe in the force. See that? And now, hey, let's go. And we go here. And my friends, do you see the triangle that was dilated by a scale factor of 2? Yes. Now it says, describe the relationship between the lengths of AC and AC prime. All right, people. AC and A prime, C prime. Okay? The relationship, well, AC, a dilation will always produce, the image of a dilation will be a line parallel to it. Okay? And is twice as big, as long. Got it? From B to A, from BA, okay? BA prime, or B prime, A prime. B prime, A prime is twice as long as BA. And same happens here. But what I think what they want, the relationship between AC and A prime, C prime, is that a dilation center at a point, okay, with a scale factor of such and such, okay, having a line segment will produce a line parallel to this line segment. It always does it. Okay, let's say you didn't have a triangle. Let's say you only had these points. Well, this will be just a line parallel to this one. Okay, all right, cool then. So that's what you write. Okay, what are the coordinates of the point? All right, what are the coordinates of the point on the directed line segment from this K -5, -4 to L 5, 1 that partitions the line segment in a ratio of 3 to 2. All right, listen to me very careful. So we're going to partition a line segment. Just in case, if you don't know what partition means, in Spanish they said, "Te voy a partir la cara." That means I'm gonna break your face. But if we wanna be mathematically correct, okay, and use mathematics vocabulary, partition means to divide. Okay, so if you have a line segment, and now I'm sorry, I'm gonna write over here, but I'm gonna write. So let's say I have a line segment. Okay, you have a line segment. Okay, so 1, 2, 3, 4, 5. All right, you have a line segment, and I said I am going to, and basically you don't know that the divisions are here. I'm going to divide this in a ratio of 2 to 3. Think of it as thousands of dollars. This is you, and this is me. How many $1,000 you getting? 2. How many $1,000 am I getting? 3. How much money does the person that's gonna give us the money need to have? They need to have $5,000. So in other words, the total right here. But anyway, you are the one that matters. So this is always gonna be your ratio. I don't matter. I really don't worry about me. I'll be fine someday. Okay? So just keep that in mind. So that's how you partition a line segment. Partition means to divide. Okay, and not always into equal parts. So now let me tell you what you really need. To partition a line segment, whether you have a graph or not, you need a couple of things. You need the slope between the 2 points. You need the ratio, and you need, remember, you are the one that matters, so you need your location. I'm gonna call location with L. So let's find the slope. How do I find the slope? Well, you have 2 points, right? 1 and 2. And I am going to zoom in just for now, and I am going to label, okay? I am going to label, hello, man. Okay, beautiful. Okay, I am going to label this point with, this is gonna be x1, this is gonna be y1, this is gonna be x2, and this is gonna be y2. All right. So what is the formula to find the slope? Easy. Rise over run means to find the slope, you do y2 minus y1 over x2 minus x1. So to find the slope, let's do this. y2, that's 1 minus from the formula, y2 minus y1, negative 4. You see, I didn't write 1 minus 4. I wrote 1 minus negative 4 over x2, 5, okay, minus x1, negative 5. And this is 1 minus negative 4. I hate to see two negatives together, so negative times negative is positive. So in reality, this is 1 plus 4, 5. 5 minus negative 5. I already went through that already, so it's 10. Okay? Oh, okay, so the slope is 1/2. No, it's not. Don't do that. Would you, okay, you know what, let me write 1/2 just in case. So, let's say this is money. Would you rather receive $5,000 than $1,000? I'm sorry, would you rather receive $1,000 than $5,000? Would you rather receive $2,000 than $10,000? No, right? Remember, we're talking about distance right here. It's not the same thing to run 1 mile than 5, to run 2 miles than 10. So when we partition a line segment, you do not, and I'm telling you right now, you do not simplify the slope. If you do it, everything will be lost. You're gonna get the wrong answer. Okay? So when you partition a line segment, you do not simplify the slope. All right, so now what else do I need? The ratio. Remember, you matter. You could care less. You could give a So the ratio. Well, here the ratio was 3:2, but you are the one that matters. So you're receiving $3,000 out of possible $5,000. Remember, this is you, this is me, but the guy that's gonna give us the money has to have $5,000. Ah, I get it. You're the best, Max. Yes. And now your location will always be x1 and y1. So your location is always going to be -5, -4. Make sense? Sure. So now, this is just the beginning. Now I am ready to start actually solving the problem. So what you're going to follow is a simple structure. To find the solution, you're gonna follow this format. Ratio, yours, right, times run plus x1. Ratio times rise. Remember, the rise has to do with the y and the run with the x. That's why I wrote it like that. Plus y1. That's it. So now let's see if it works. Okay, so my ratio, I'm gonna just make a separate area over here. My ratio is 3/5. I'm gonna multiply by the run. Which is the run out of this and this number? Exactly 10 plus x1, meaning your location. Which one's your location? Right here, -5. Oh, okay, plus -5 equals. Then again, here, 3/5 times the rise, which in this case is 5, okay, plus x1. No, not x1, y1, I'm sorry, which in this case, your location is -4. Okay, so let's see now. There are two ways in which I can do this. I could just plug it in the calculator, like this, on, okay, and let's see. So if you have a TI-84 plus, right, then you could press alpha, okay, alpha y equals, and you get numerator over denominator, okay, the fraction type. See that? And I am going to input what I see over here. 3/5, okay, times 5 plus -4 or just -4. I really like don't like to have two signs together. I don't know who invented that. And I get -1. Now I'm gonna do the top, which I should have done first, right? Sure. Okay. So again, alpha y equals fraction, right? And I'm gonna do 3 over 3 over 5 times 10, okay, plus -5, or just -5, 1. Okay. So anyways, I just use the calculator, but I could do it by hand. I'm gonna show you. Can you just become clear again? Oh, okay, this is getting better. So look, when you multiply by a fraction, you multiply by the top and divide by the bottom. All right, so 10 times 3 is 30. Divided by 5, 6. 6 minus 5, 1. 5 times 3 is 15. 15 over 5. 15 divided by 5 is 3. Plus -4, or 3 minus 4, -1. And that's basically how you do it. See? Not that difficult, right? All right then. So I am going to stop right now. Okay? We did 9 problems and we covered like maybe 4 topics in constructions. So please remember, if you understand these, you will pass that common core geometry crap. Trust me. Believe it. All right? I'll see you on the next video.